Hello everyone, welcome to my channel. I am Chief Patel. In today's lecture, we are going to start an important topic of physics, which is electrostatics. We will understand electric charge, electric force, and finally Coulomb's law with some examples. Before starting the theory, let's think about some daily life examples. Have you ever rubbed a balloon on your hair and seen it to wall? Or have you ever felt a small electric shock after touching a metal object? Or why does a plastic comb attract small paper pieces after rubbing it on hair? Why does it happen? It is due to a static electric charge. So let's find out what is static electric charge. Electric charge is a physical property of matter responsible for electric force. Now, I hope you know the what is a gravity. Okay, so in gravity, you heard about mass. Gravity works between two mass objects on this same manner in electric force. The responsible thing is electric charge, which is denoted by a Q or capital Q. Let's talk about types of charge, which is there are two types of charge, positive one and negative. I hope you heard about protons and electrons. Here I have shown you a structure of atom. There is a positive charge in middle of the atom and electron revolves around. Now, let's talk about basic properties of charges. Like charges repel each other. Unlike charges attract each other. Now, I talk about positive charge and negative charge. So, when there is a two like charges, there is a between a repulsive force in between them. When there is a two unlike charges, like one is a positive, one is negative charge. In between them, there is a attractive force work. In every system, according to physics, charge is conserved in every process. Now, let's talk about the SI unit of charge. The SI unit of charge is Coulomb, which is coming from the name of the scientist Charles Augustin de Coulomb. He was a French physicist who experimentally discovered the relationship between electric charges and force using torsion balance. If we want to understand the force between these two charges, we have to understand the Coulomb's law. Coulomb law states that the electrostatic force between two point charges is directly proportional to the product of their charges, which means F proportional to Q. Let's suppose one charge is Q1 and the other charge is Q2. Now, and inversely proportional to the square of the distance between them. Let's suppose here is Q1 charge and another charge is Q2 here. And let's suppose the distance between them is R. Now, according to the Coulomb's law, the electrostatic force between two points is upon 1 upon r squared. Now, let's combine together. We get Q1 Q2 upon r squared. Now, let's go on. Now, we get F proportionality constant Q1 Q2 upon r squared. Now, you know, if we have to replace proportionality constant by equal to, we have to add one constant. Here I add k constant rest like this. Okay. Now we understand one by one term. Okay. F. F is the electrostatic force. The electrostatic force, it is a charge are caused to feed the museum electric rotation. Now F, you know, force is vector quantity. It has magnitude as well as force direction. Let's first talk about magnitude. Now, if we talk about magnitude, we write like this: K Q1 Q2 upon R. Now, Q1 we know first charge, Q2 is second charge, R is the distance between two charges. Now, what is the value of K? Before talking about the value of K, what is a K? K is equals to 1 upon 4 pi epsilon naught. Here, what is epsilon naught? Epsilon naught is vacuum permi- permittivity. Now, the value of the K is 9 into 10 to the power 9. If we talk about K, unit of K, which is we can derive easily, which is K is equal to F R square on Q1 Q2. We know the what is the unit of force, which is Newton. R square means meter square upon Q1 Q2 upon Coulomb square. So we get the unit of K. Now we talk about later this with the two problems. Now, as I mentioned earlier, force is a vector quantity. So we talk about magnitude of it. Now let's talk about direction. The force acts along the line joining two charges. What does it mean? Let's suppose I have Q1 here and Q2 here. The distance between two charges, let's suppose R. Now, let's say this is the positive charge. This is also positive charge. As I earlier said, two like charges repels each other. Now, Q1 acts on Q2 to take force in the direction of this. Let's take this positive x and this, let's say, negative x. It's x direction. So force due to Q1 in the x direction. Now let's talk about Q2. Force due to Q2 on Q1 in the direction of negative direction, like this. Now here I write attractive force occurs between unlike charges. Here you see a positive charge and negative charge. They attract each other because they are different and unlike charges. Now the repulsive force occurs between like charges, like a negative negative attracts each other, like repel each other, and the positive positive charge are repel each other. It is very easy concept. Now let's move on. Now here we compare the gravitational force and electrostatic force. Now before going to that, I have to mention that there are four fundamental forces. They are gravitational, second one is electrostatic, third is strong nuclear, and last one is weak nuclear. We talk about this first and second. This strong and weak nuclear force is related to the nuclear physics. Now, now compare the gravitational force and the electrostatic force. We compare it on the basis of origin, direction, magnitude, and dependency. Now, let's talk about origin, the exist between masses. In the starting of my video, I said that the gravity, or you can say gravitational force, works on between two masses. If I have a mass m1 and m2, they experience gravitational force. But for the electrostatic force, we need two charges, whether it is positive or negative. On the basis of the nature of the charge, they repel or attract each other. Now, the second one is the direction. We know that the gravitational force is always attractive, and the sign of the gravitational force is always negative. On the other hand, the electric force, which can be attractive or repulsive, on the basis of sign of Q1 and Q2. If Q1 and Q2 both are positive or a negative, they repel each other. If one of the negative and other one is positive or vice versa, they attract each other. Okay. Now, let's talk about magnitude. In in the four fundamental forces, the gravitational force is the weakest one, and the electrostatic force is the second strongest force. Uh, Let me write the strong, then after electrostatic, then weak nuclear force, and the last one is gravitational. Okay, and gravitational force is the weakest force among these. Now, at the last, dependency. We know the gravitational force which is given by like this G M M upon R square. G is a gravitational constant, and this is the first mass, second mass, and the R square, which is dependent on mass. On the other hand, electrostatic force, which is given by K, Q1, Q2 upon R square, which is depend on Q1, Q2. Now, let's go. Now, from the formula which I given earlier, F is equals to K Q1 Q2 upon R square. Use this formula and take answer of force. Okay. So before going it on it, I will do it now. Let's suppose let Q1. Let's some example. Let's suppose Q1 is equals to 4 Coulomb. Q2 is equals to 6 Coulomb. And let's suppose R is equals to 1 meter. Okay. Now we have to calculate the force and the magnitude also. Now the answer, let's, what is the formula? K Q1 Q2 upon R square. Now what is the value of K? Remember K value 9 into 10 raised to 9 Newton meter square per Coulomb square. You don't forgot the unit, okay? 9 into 10 raised to 9. What is the Q1? Q1 here is the 4 Coulomb. What is the Q2? Q2 here is the 6 Coulomb. R is the 1. What is here? This is the answer, okay? Now we have to find the direction. Here both charges are positive. So what is it? Here repair it. So whatever is negative, what is the direction? Let's suppose take Q1 here, Q2 here, and I will take this as x-axis. Okay. The force due to Q1, let's suppose, which is F, and the force due to Q2 minus F. This is the deflection and this is the magnet. Okay. So it's your turn to do this. Pause this video, try to do yourself, and then I will explain how to do it. Now, let's, as I say, write formula, which is F equal to R square. Substitute these values. Here is a catch. I here mention is a microcoulomb. This is not a coulomb. If you forget this, your answer will be wrong. So you have to remember 1 microcoulomb is equal to 10 raised to minus 6 coulomb. If you forget this, then your answer will be wrong. So if we simplify and we got the answer is 0.216 meter. The final answer is this one. Now let's go on. Problem 2. What says Q1 is 4 microcoulomb, Q2 is 6 microcoulomb. The distance between two charges is zero point 0.5 meter. Now you know what is the formula and substitute this value and you get this answer. Now, as I say earlier, this come into picture, okay? Now, problem 1 has a 2 microcoulomb, 3 microcoulomb, zero point 0.5 meter distance, okay? Now, we do multiply by 2, multiply by 2, okay? And the distance is same as it is, okay? We get the answer is 0.864. Now, we got the answer in problem 1 is at 0.216 Newton and problem 2 is 0.864 Newton. The relationship between this, okay, it is a multiply by 4 because we do, let's I write this formula, okay. Now if I multiply by q1 is equal to 2q1 and q2 is equal to 2q2. Now I have to put these two values in this equation. What I got for k q1 q2 upon r square, okay. Now let's suppose I do f prime is equal to, we got 4f. It's very important concept. Now directly proportional to charges, what does it mean? If you increase the charge, magnitude of charge, force will be increases, okay. Double the charge, force become double. On the other hand, the force is proportional to 1 upon r square. What does it mean? If you increase the distance between two charges, it becomes 1/4 of the original one. Okay, this is a very important concept, and this is how the force is related to charges and distance. Okay, now this is a danger zone. While you solving a problem, the students met many problems with it. As I earlier said, microcoulomb, coulomb. Now, in the exam or while solving a problem, read question twice and make sure what is the unit. Okay, sometimes they will give nanocoulomb. So, what is a nanocoulomb? 1 nanocoulomb is 10 raised to minus 9 coulomb. Okay, so mind in your while you solving a problem, read question twice and the unit. Okay, I write like this and write down in your book. And next time, two. What is here? Sometimes student write in hurry. They write this. We have we have square here, not only R. Okay. So keep in your mind. Now, what is the real world application? So there are many real real world application. First one is a air purifier, smoke, but using the electric friction to pull dust and smoke particles out here in the dust. If there are charges in there, so attraction and repulsion are there. Okay. Now we have a laser printers and photocopies also, and for the painting of any body. Okay. Now I talk about all of these things, the electric charge, what is force, and we do some problems on it. Now it's your turn. A quick conceptual revision. There are few five questions here. You have to answer it on your own. Okay. What happens between like charges? What is the SI unit of charge? What happens to force if distance doubles? Is electrostatic force effective only or not? Who discovered Coulomb's law? No, these are conceptual revision. And one other thing is the homework. You have three problems. Find the force and what happens to force if distance becomes three times of its original value. I talked about earlier what happens. Right? The application. Okay. Now, now take some I use here. I use a PHET simulation to understand concept well. Now, I have a balloon here. If they have a containing also positive and negative charges here as well and here as well. Now, I take this balloon here to the float. See the negative charges in the balloon. Now, see this. This is attraction. Here, here it is a positive charge, and in the balloon there is a negative charge. So they attract each other. As I told earlier, here as I move towards wall, the negative charge it is repelled because balloon contains negative charge and it sticks. Why? Because it has some positive charge also. Now, for Coulomb law, let's take charge 1 minus 4 Coulomb, charge 2 8 microcoulomb. Okay. Now, you can see here force on Q1 by Q2. Here's a Q1 force due to Q2, which is 319.557 Newton, and force on Q2 by Q1, which is same. Okay. Now, if I change charge 1 minus 5, values will be different. Okay. Charge is same. If I distance for then also the value will be you can see here the values is different, which is also depend on R. This is the illustration of Coulomb's law. Today we learn the basics of electrostatic and Coulomb law. Try the homework question and keep learning physics. Thank you for watching. Subscribe for more physics lecture.